we go. We are going to run and bike and swim a triathlon. And then we will die. At least that's what I would do. The Ironman triathlon is a race that consists of 3 different parts. We have a 2.4-mile swim, which just on its own sounds beyond terrible. We have a 112-mile bike ride. And then we have a full 26.2-mile marathon. You know, just because we hadn't done enough. Crazy people. A participant swims steadily at 2 miles an hour. So I'm matching up the part of the race with the speed he's going, or let's make it that she's going during that portion. So during the swim, she's swimming 2 miles per hour. During the bike race, she is riding at 20 miles an hour. That's pretty fast on a bike. Yeah. And then we are running 9 miles per hour. I would think for a marathon, that's a pretty good pace. I'm no expert. Megan, you're a runner.
Yeah.
That's a pretty good marathon pace. All right. So if you're familiar with a triathlon at all, you know as soon as you get out of your swim, you have to put your biking gear on. You have that transition time. We're, for the purpose of this, eliminating that time, okay? So assuming that we're not losing any time during those transitions, we are looking to find a formula for the distance covered in miles as a function of the time from the beginning to the end. We're going to graph, write the function, and then talk about the domain and range. So, here's where we need to start. We need to start with the amount of time it took for each part, for each portion of the triathlon. So how can we figure out how long it took her for the swim? I highlighted that stuff on purpose for a reason. Can we figure out how long she spent swimming? Laura? Not a proportion. Jonathan?
Just divide 2.4 by 2.
Yeah. Okay. So the swim is 2.4 miles. If she went 2 miles per hour, that means it took her 1.2 hours. And then we can do a similar thing for the biking and the running. So for the bike, it's 112 miles at 20 miles per hour. 5.6, thank you. And for the running is 2.91. And these are all hours. So the total time that it took her for the triathlon would be 1.2 plus 5.6 plus the 2.91. Thank you. So at this point, we can talk about the domain and the range. So going, I don't know, slightly out of order if you want to consider it that way. But we can talk at this point about the domain and range of this. Before we do that, though, we need to understand in the context of this problem, what is the domain, what is the range? Basically, what's the input, what's the output? In the context of this problem, what is the input, which would correspond to the domain? Carly? Time. So, I don't want to say too much. So if time is the input, what's the domain? Carly, what do you think?
Is it like the whole domain of like every part? Like all three pieces?
For the whole thing, for the whole triathlon. We're gonna, when we think about this, when we graph our time, where are we gonna start and where are we going to end? We start at 0. All the way up to what?
9.
Exactly the total time it took her. If time is the domain, or I shouldn't say that, if time is the input, what's the output? Michaela?
Distance.
Okay, so if distance is the output, what's the corresponding range? Yeah.
0 is less than or equal to y, which is less than or equal to 140.6.
Very good. Where'd you get that 140.6?
Added up all of the miles.
Yeah, that's the total distance she went. Okay. Okay. So far, so good. Here's where it gets a little tricky when we're writing these formulas. Hopefully you have seen in other classes before that distance equals rate times time. Yes?
Yeah.
I don't know, physics maybe, or some place.
They never like that.
What?
Like algebra 1.
Really?
No, I'm just another algebra.
Oh yeah, you do those like distance problems in Algebra 1. That's right. Okay, good. So that is what we are going to use to figure out the distance for each portion. So for the, what do we do first? The swim. Distance equals rate times time. For this, the distance is going to equal our rate for the swim, which is 2 miles per hour times whatever the time is. This is our easy one. Let's go ahead and put this part then into our final piecewise function. So the distance equals 2t between the times that she is swimming. So for only t values between 0 and 1.2. All right, next we do the bike. Distance during the bike race, again, is rate times time. Her rate on the bike race was 20 miles an hour. But here's where we have to think about during the bike race, this is the total time minus the time she spent swimming. That is how we have to express time during the bike race. The total time, but minus the swimming. So we could distribute our 20. But guys, this is only the distance for during the bike race. She's already gone a distance. She's already gone how far? How far has she gone if she's in the biking? 2.4 miles. So we have to add on that distance that she's swum? I don't know. Yeah. So we need to add that on. This expresses the distance correctly during the bike race. Okay, last part. Now we're looking at the run. It's going to be pretty similar. We have our rate, which for the run is 9 miles an hour. Her run time is the total time, but minus the time that she spent swimming and biking, which is a total of 6.8 hours. And then we need to add on the distance she's already gone from swimming and biking, which is a total of 114.4. And then you can distribute and simplify. During the time that she's running. Laura.
Why wouldn't the middle one and the start of the third one be just greater than and less than?
Oh, it totally should be. Thank you for pointing that out. Thank you. It should be. I don't expect you to do this on a test. So, yeah. You can take a sigh of relief. In a group during class, maybe. On a test by yourself, no. Does that mean we're not going to do a hard problem? No. But in groups in class is more where we're going with something like this. What I would expect you to do on a test, graph a piecewise function, write the equation of a piecewise function from the graph, so kind of back and forth from that first page. Okay? But this, no. So you can not cry. All right, I'm not going to take time, but I'll show you what the graph looks like. So So between the time of 0 and 1.2, we swam that distance. Between the time of 1.2 and 6.8, we can see that our distance really goes up quite a bit because that's the big distance that we travel is when we are riding our bike. And then between the, 6.8 and 9.71, we have our distance that increases there a little bit, okay? Alrighty, last thing, this will seem like no big deal. Okay, last thing that we need to talk about is the absolute value function, okay? The absolute value function is defined by a piecewise function. Not sure if you remember what, in general, the absolute value function looks like in terms of a graph. It's the V. It's the V. Looks like this. That's not going to be super accurate, but in general, that's your basic absolute value parent function. So you can see that when your x values are 0 and greater, it's doing one thing. When your x values are less than 0, it's doing another. It's using the function x when x is greater than or equal to 0, and negative x when it's less than. I don't know why I keep doing that. Courtney, what's the domain of that?
X is greater than or equal to 0.
I have,
Oh, it's all real numbers.
yes. Your domain is all real numbers. Alex, what's the range of this? I'm sorry, what?
Y is greater than 0.
Close.
Greater than equal.
There we go.